Oh, there was no voice this time. Okay, I think it's recording. I see a recording button. All right. Usually there's a little lady voice that like says, "Oh, recording" or whatever. I didn't hear it, but I see it going. Okay, so yeah, first of all, it's great to be back and everything. So these next couple sections, well, okay, from my understanding, you guys are supposed to be going into section 37 of mod 4, which is the introduction to time series. And then later on this week, we'll do section 38, which is kind of the continuation of time series, like applying time series modeling. Does that sound right? Just give me a quick thumbs up if that's about right. Cool. So Eli probably has gone over with you guys. I'm just kind of looking over real quick on the curriculum. You guys went over, not PCA. No, you guys talked about PCA, clustering, big data like PySpark and stuff like that, and the recommendation system. Is that right? Yeah. Yes, those are some pretty heavy topics, to be quite frank. PCA, clustering, big data, recommendation system, that's a lot going on here. And that's kind of what's this, like, I will say is that like literally almost like every section in this module could be its own separate course. Like literally going deep dive into, you know, whatever it is. Like, you know, we're going to talk about time series over the next 2 sections, but there are people who literally study time series like really in-depthly, you know, like, and are probably honestly better experts than I am in time series. And same thing happens with NLP, neural networks, and you'll see it in neural networks is kind of the last thing, one of the last things we do. And there's like, I'm looking at it right now, it's like 1, 2, 3, 4 at least, or maybe 3, almost 4. Yeah, 3 different sections of like, you know, deep learning and stuff like that. And I can tell you right now, there's so much more to deep learning than what we're gonna talk about. But I like to think of this like, module as kind of being like almost like the elective bag of like, all right, here's the other stuff you should be kind of familiar with, and if something really catches your interest or you run into again in the future, you have enough knowledge to kind of like get your stepping stone and kind of like your foothold in and kind of move forward. And that's kind of what we're going to do with time series today. But before I do that, and this is when I said I should share my screen, so I have to pull up this doc and I'm trying to remember what I called it. Okay. So you guys might remember this, and I'll share it in the chat too, but let me share my screen. That should be it. Okay, cool. And oh yes, I remember. Everyone moves over. My windows get moved around. Okay, so give me a thumbs up if you guys can see office hours and discussion questions. Cool. So you guys probably remember this. I don't know if Eli had something similar, but I'll share it on the chat right now. Oh my gosh, it's been so long, guys. I don't remember how to pull up chat now. There it is. It just disappeared. Okay, so I will share this doc if you guys forgot where it is. And basically, reminder, and then Uma, I know this is new to you. What I have you guys, if you guys have any questions, you know, kind of put this in here, especially like the sections, like, you know, if we have moved on to, you know, time series, for example, if you want to talk about, you know, something about big data, you want to talk about something about recommendation systems, this module in particular is probably the greatest like module to do this, because there's so much you can like to ask about, and we can go more detail, or at least I'll do the best I can. And if you do it ahead of time, it makes it a little bit easier for me to take that time to like research a little bit, especially if it's something a little deeper. But we can definitely take that time, maybe at the first, like, you know, 10, 15 minutes, you know, we can like at least go into some. And then if things are going like really like, oh, like we want to talk a whole bunch about this, maybe dedicate a whole, you know, study group time for it. Okay, cool. All right. Any questions about this? I think it's pretty self-explanatory. It's just kind of free form. I think we have a history down here too, so you can see like our old questions that we used to ask and stuff. And I know we usually use this for like office hours when we had our project, but there's no reason why we can't keep doing this for our different sections. Cool. All right. So cool. And I see Alvera. Hey, Alvera. Oh, I see you and Mike are in the same place, the same beach. It's nice. All right. So let's go right into time series. So time series is going to be, again, like 2 sections. We're going to talk about mostly section 37, which is going to be introduction, time series, visualizing a time series, and then we're going to go into trends. I almost guarantee we're not going to finish the trends section, but that's okay, because that leads really well into modeling. So basically, in section 38, we talk about how we take a time series data and actually model it. And it's one of those things that's really interesting, but the idea for time series is we're kind of looking for patterns. And the funny thing is that with patterns, we're trying to actually going to remove those patterns, because if we know a pattern, then we can predict it. It's the stuff that we can't predict easily, like a easy pattern based around time. That's the kind of the interesting stuff. That's the stuff like we can't necessarily use just time by itself to predict things. Does that make sense to people? Okay. Cool. One example I like to do this is like, my house, for example, it gets hot, hotter throughout the day and then gets cooler at night. And that's going to be true no matter what time of the year it is, if I have the windows open or whatnot, right? It's always going to get a little bit hotter and a little bit colder, right? I'm going to see this pattern. If I know that pattern, there can be subtle like differences if I turn on my AC, if I open the window, if I literally am like taking like breathing on top of like my temperature sensor. Like those are the things I can account for just by time. And that's kind of like what we're going to see in time series. Okay. Cool. So before we going into that, this will be into like next time. First, let's talk about like what is a time series, right? So time series data really is just more data, but there's an important aspect of it is that the temporal information, meaning the time, day, it could be minute, could be hourly, could be seconds, could be milliseconds, basically is the focus of the data. So if you ever ask yourself and you get a data set and you're like, is this a time series? Ask yourself, does the time, sorry, I'm trying to make sure I phrase this correctly. Does the data, or do the data focus the most on time? Like, is that the thing that's the most important? So if you think back to, what was your first project, right? With, I think it's the first project with the housing prices and stuff like that. If you guys remember make predictions. Some people notice like, oh, it has a time, when the time of sale and stuff like this, but that wasn't the main focus, at least for what we were looking at. Main focus of the data. The main focus of that data is like, what kind of house is it? How many bedrooms? How many, like how big of a house it was. But there was time information, but it might have been argued you could see it from a time series perspective, but our main focus was not on the time itself. If instead we're looking at time, for example, like change of temperature over time, right? Obviously the time is going to be a huge focus. Financial data usually has a huge amount of focus on the time series aspect because the biggest thing is like, hey, what's the price of, the stock, over time, what it should be invested in, and what can we make predictions for the future on like when we should sell that stock or buy that stock or whatever. Okay. Does that make sense to people? Okay. I'm seeing nods. All right. Any questions so far? Yeah, go ahead, Jessica.
More of just, I have an interest in like the energy sector. So it makes me think too of like energy markets and like energy demands and usage and stuff.
Oh, absolutely. Yeah, like I'm sure I don't know if you're familiar with the duck curve, for example, for solar panel or solar power. So what's interesting about solar panels is a big deal. I don't know if you guys have noticed this, but people have been using a lot of solar, right? Like recently, like almost every other house you look at, and pretty much in the whole country has solar on it, right? Like you can kind of see this like compared to like 15 years ago. Well, one big thing about solar is that when does it generate the most electricity? Midday, right? When do people tend to use electricity? Not during midday. Most people are at work, hanging out and doing stuff. When they use it the most is usually about that 5 o'clock, basically when people start getting back from work. And so it's interesting, there's energy companies are really interested about this thing called the duck curve, where basically the use of the production of energy is really high during this day, but then the actual use of it is during the nighttime, which is, or like in the evening when production of solar power is very little. And so they talk about, it's like, well, okay, we have a whole bunch of power up here, but then later in the day, we have it like used up a whole lot, like we're using a whole lot. And like, how do we compensate for that? And there's interesting ways energy companies are trying to do that. So again, like you can see immediately, it's like, oh, time series can be really important, being like, if you can make that prediction, and they do, because also, I mean, we can go on and on about this, but basically time is really important for like energy, and you see it in a lot of different industries for sure. The reason why we have 2 sections on this, even though it's more niche, than like some of the other data, time series just comes up all over the place. So it's useful to kind of know the terminology and kind of like the strategies. So yes, but thank you. But other examples too, right? Stock prices, like I mentioned, temperature over the year, that's kind of, you can kind of think about this. This is actually what we're going to use these two the most because it's easier for us to play with. And you can get that data pretty quickly. Atmospheric changes over the course of decades. So you can think of things like people looking for, studying global warming, climate change, right? Seeing, like what is this being affected and stuff like that, make predictions, and, what are things we have to look out for. A big time series right now, as you guys probably are familiar in this time in the world, is probably the coronavirus. There is some time aspect to that. Now, is it purely based on time? No, right? It depends on how different countries and different, communities react to how they deal with the coronavirus, right? But there is some time series in there where we can actually make a prediction of saying, well, where do we think this virus will go based on what our current, like parameters are. Saying like, are people wearing masks? Are people not wearing masks? Are people going out, hanging out in bars when they maybe shouldn't be hanging out in bars and stuff like that. All this good stuff. So again, time series is really important because our whole life is pretty much driven by time. All right, so I'm gonna kind of move on. That's our introduction, took a little time, but now we say, all right, let's get some code, right? So most of the code I'm gonna show is kind of very similar, if not directly taken from the curriculum. So you'll see some very similar stuff. I think all the data sets I have in this next few notebooks, it's literally the same data set. So you can play around with it the same way. So you might see me do something different than the curriculum is, but that's just to kind of show you like there's differences. All right, so we have this min-temp CSV. I'm actually gonna pull up that CSV. Oh, this is not it. Sorry, this is from the repo, right? I'll make sure to share that with you guys. So this is the min-temp CSV. It's just useful to look at it really quickly. And so if anyone gone through the curriculum already for section 37 or at least started it? Okay, see a thumbs up, see some head shakes, right? One of the first data sets they show you is this basically minimum temperature. And this is supposed to represent basically the temperature is taken every day and the minimum temperature is recorded for this particular area. So for example, here, it is actually day, month, year with 1981. And so I think this temperature, I'm gonna assume it's Celsius. I actually don't know if it's Fahrenheit. I think it's Celsius, but who knows? Doesn't really matter to be honest, because it's gonna still scale up and down, right? But the important thing to note is that this is day, month, year. So this is January 1st, 1981, January 2nd, 1981, so on, right? And there's just two columns, the date and then the daily minimum. Okay, so important to note. So note that I just pulled this up right here. Like obviously, like there's not that many rows, like there's only 3,600, right? At this point, 3,000 should be like nothing to you guys, like, oh, that's like nothing. But obviously if there was like literally millions of rows, this would be a bigger deal. Kind of fun thing, maybe I'll show you guys later on when we have some other time. I actually been taking data from my babies. They have this little, like this thing called an owlet sock, which is an oxygen oxypulsimeter, and it basically takes like their heart rate and their oxygen level, and it does it every 10-ish seconds. And I've been pulling that ever since I've been able to get that sock on them. And so I have huge amounts of data, something around like 5 million data rows, I think right now, on like the thing. And so obviously you can't just simply open this up. I mean, you could try. I think that one's relatively not too bad. Like I think the whole data source is about less than 400 megabytes. But what you can do on a powerful enough computer, but you also probably shouldn't get into that habit. So note that I can pull this up, but we should probably use like loading it in a chunk or something like that. So anyway, it's good to know our data. And so we're gonna load this data into a CSV, nothing too crazy. And again, oops, gotta actually point stuff. There we go. All right, and so just kind of quickly looking at it, we can see our head, which we saw over here. And what's nice is Pandas, or I guess Pandas just reads it in, where's my data? Sorry, what's up? You can see it just read it in, right? Like normal. Now, you'll notice right here is that non-null object. Now in new Pandas, I can't remember what version I'm using on here in Learn Environment. Learn Environment using older Pandas. In newer versions of Pandas, as you guys will see later on, probably as your career, this can be string as well as object. So this might actually come up as string, but basically non-null object basically says, oh, it's not a number, it's not a thing. Usually we interpret object as a string, but it could be other stuff. So the main thing is that this is not actually treating it as a date. It's actually treating it as a string, which is fine since we know how to read this, but it'd be really nice if like Pandas immediately knew it was a date, right? Because then we know like, oh, it's like 1981 versus like trying to pull out the exact number and all that stuff. So what's really cool is that Pandas actually lets you do this. So this is the one way the curriculum shows, and I'll show you guys later on in today a different way of importing the data, which is it looks a little more cumbersome, but it's actually pretty useful if you do it right. So note that we're just taking our DF temp, which is what a DF temperature.
Would that be using the type when you load the data frame and identify the type for the column?
It's actually a little more subtle than that, or it's a little more complicated. I should say more complicated than that, because even though you know it's a date time, date times can be represented in many, many different ways, right? So we'll have to use something called a parser. And is anyone familiar with the word parser? This is something you'll hear one more time. So parsing basically just means that you're reading in data, right? And you're going through it and you're parsing through it in the sense that you're converting it over into something else. In this case, when we say a parser, we're saying, oh, we're converting this string, like this guy right here, and converting this into a valid date time. I'm going to show you guys possibly today. Actually, I noticed in the curriculum actually makes a mistake where they parse this incorrectly and it actually shows it in by, like they actually forget to do day, month, and it automatically imports it as month, day, which is more of the US system, which unfortunately means that their data looks actually a lot more fuzzier than it should be. Maybe we'll get a time to check that out today. But yeah, so we're actually gonna have some special stuff we're gonna call in Pandas. I'll show you guys in the next notebook. But in this one right here, we're just gonna be very upfront. We're gonna actually convert it to a date time. So this can be useful even if it's not the index, which is the main focus. So this could be done, for example, the King County data set, right? Or something with like date time in it, but you don't really want to use it as an index. You can convert a certain column, in this case, the date, right? So remember, this is just a series here. Taking that series, converting it to date time with the Pandas library. So remember, this is a Pandas function right here, applying it to a series and saying the format. So this format right here is basically using this date string. And we're saying basically that, hey, the format of this is going to be day, month, year. Now, the big question, you're like, oh, how do I know it's %D like versus like %M? And this is where it's really nice when you learn all this stuff. But when you're first learning it, you're like, how do I know what letter to use? And the short answer is you got to look it up. There's actually a resource in the curriculum that shows you like how to do a date string. But if you literally just search date string, you will see all the different options here. Let's see if I can find it really quickly. Yeah, doesn't even matter what language it is. What's nice is that formats, there we go. Date string formats. And what you can do, it's probably, I was searching JavaScript. Or, there you go. I should have searched it beforehand. All right, maybe it's not as a simple search as I did, but let's take date string format Python. I'm kind of thinking like what you would do, like if you were in this scenario, like I don't know how to change this, right? Is that I'm going to click on the first result because Google is pretty good usually, and you can see that there's different stuff to change out. Oh. All right, tell you what, guys, I take it back. It's not as easy as searching for it. I don't know why I'm not finding it quickly enough, but I will share you guys a resource. If you do different, if someone wants to look for it real quickly, basically the main thing you have to do is that you pass in certain parameters in the string like this, and those stand for different stuff. And this can also be for outputting and reading in. But in short, right now, we're just gonna use this simple guy, okay? Make sense? I know kind of like, I'm skipping over something like, oh, it's really easy, but oh well. All right, so we're gonna read it in this date, month, year, just like in that format. And then we're going to go ahead and set the index. So why are we setting the index to this date? What was the reason? Someone want to summarize why we were setting this index to date? Like it's not necessary, but it's useful. Any idea?
I don't know, for plotting?
Say again? For plotting?
For plotting,
yeah.
Automatically becomes your x-axis.
Exactly. Pandas really likes, if you set things as your index, Pandas knows like that's a first class citizen column. Like that is an important column. And since we're doing time series, we're saying, hey, the time is like the most important aspect of this whole data set. So that's why we set the index here. And what's nice is that we'll see that you can kind of manipulate the data frame really easily because it knows the index is the actual date time. So now what happened right here, I converted that date into a date time. And if I actually go ahead and put out the head for the first 10 rows and the info, you can see here, first of all, you see the index, right? With it lower down, right? You can see that's an index, it's in bold. And you can see here, hey, it's like in a readable format. And this is considered like the standard format. You would have year, month, day. One of the reasons why we do this is because we can actually sort by year a lot easier if we do it, or by date if you do things like this. So usually you'll see someone start with the largest value, a year, like the month, the day. You might go into then like the hour, and then the minute, and then the second. And that way it's kind of reading like left to right on making the date smaller and smaller. Okay. So, and you can see here, we can actually check out the type, right? You can actually see it because it is an index, right? You can actually see it says 1981 01, 2, 19, 12, 31, which is nice. And you know that it's a date time index. So it did pick up the actual date time. Just to kind of quickly show you what happens if I don't put index in here. Oops. What happened here? What didn't I like? Oh, I have to re-import it. Let's do that real quick. Okay, if we do this, you can see it didn't really change anything on here. Oh no, I'm sorry, it did change it because we did date time, so you can see it's date time, but you notice that there's no index, but you'll see that it's also figured out what the type is. And we're just treating it index because it makes it nice and pretty. And so let's just do it like that. Just to make sure. I don't want to rerun it again. There we go. So now we're all set. Okay, so now we got this data set all loaded. You're like, cool, like that was not very much code, but it's helpful to kind of understand what's going on here versus just doing it blindly, right? So next part, it's like, okay, look, what can we do with it? Well, what's nice is like we can actually slice the data. So if you look at this real quick, this probably makes a lot of sense when you read this, right? After 1990 equals DF10, 1990 onward, right? But if you think about this for a second, you're like, wait, like I'm not passing a specific column. It's just saying like, hey, like take 1990, the string, and onward. And what's cool is that Pandas knows, because we treat this as the index, it knows like, hey, look at the index and look for 1990 past that point. And you can actually see when I display this now, you can see I only get 1990. And if I kept going on, I only got the first 15 days. But if I went on and on, right, you could see that it went all the way for 1990. And just to prove that I didn't change DF temp, you can see here, I still have 1981, and then it goes all the way, I think it went to 1990 or 1991. There it goes. You can see it goes to the very end here, at least for the full data set. So note that if I didn't treat this as an index, you couldn't do this, right? Which you think about it, that's really convenient, like be able to pull up the specific year and just like go from there. And note that it knows that like this is the year. It's not like doing something else. Like, oh, it knows that that's specific about the time. So really useful stuff. Okay. So like I mentioned before, I'm just kind of going through this. Why should we make the date as the index? We're making the date column as the index because it's a time series. That's the most important aspect of it, right? That's kind of like the focus. It's kind of like, you know, Avera mentioned, like almost like the x-axis. So like when we plot it, it would just be the x-axis, and usually time will be on the x-axis. Okay, cool. Any quick questions about anything I kind of went over, loading and slicing? Okay. Pretty understandable. Yeah. Okay. I know I talk more than I actually code, right? Like you can see, like there's almost no code here, but I think it's useful to understand what the code's doing. All right, so let's talk about resampling. So resampling can be really particularly useful, especially when your data set is different from what you want it to be or the expectation of the data set. So what I mean by this, like let's say, for example, you have multiple sources. So for example, let's say I have temperature sensors throughout my whole house. And let's say for some reason, one of the temperature sensors, I set it, or maybe the hardware is only able to take temperature every hour. But or like averages over an hour or something like that. But the rest of the temperature sensors do it every minute, right? So it's useful. It's like, well, what if I want to combine these together? It's like, well, I want to just simply combine, you know, let's say 11 a.m., you know, in this room, but then every other house goes like, or room in the house goes 11:01, 11:02, 11:03, 11:04. If I combine 11 a.m. with my data set that has 11:01, 11:02, also 11:00, right? It would think that when I combine them together, that the room in here that was averaged over an hour is just going to be 11:00 and then just null values for everything else, which isn't really accurate when you think about it, right? It's really saying that's the average temperature over the whole hour versus like saying a specific minute. So this is where resampling can be really useful. This is also really useful, like, or really common like financial data when you want to make sure you combine these things together and seeing like expanded outward, where you're like, okay, I don't care about like the specific, you know, let's say like day or time. I want it kind of like averaged over like the month or something like that. This happens a lot in finance. So there's two ways we can do this. We can either downsample or upsample. Downsample basically means that we're going to reduce, right? Upsample, we're going to increase, and we'll see what that means exactly. I think it's more useful to look at an example. My mouse is frozen. My mouse is frozen. There we go. Okay. All right. So downsampling, just kind of know, resample at a lower rate. You may lose information because we're basically getting rid of some of that information, but we're making it so it's essentially like more summary, like more of a kind of condensed version. What's nice, it is more computationally efficient. So imagine if I take data temperature every second in my room, right? Probably not that's like super like useful information every second unless my room is fluctuating like crazy, right? Most likely every second's overkill, right? And I can at very least like downsample to like 1 minute or even like 1 hour. Like 1 hour might be sufficient enough, or even every 15 minutes, right? It could be something like that. So that's kind of the idea where it's more computationally efficient. You don't have to process all the data for every second, where really every second doesn't really matter. Okay, so some examples of this, and I think this is from the curriculum itself. We're getting monthly data, and note that it's df temp, which is what we had before. We're going to do .resample, and then ms. To be honest, I can never remember like what the different values are here. This is where you'd have to like honestly look it up. I have to look at it every single time. But know that month basically means like we're doing the monthly mean. We're doing a monthly sample. I don't actually know why it's ms, to be honest. But we're basically take it by month, and then we're going to say, all right, what's the month mean? Monthly.mean. So if we look at this now and see what the results, you can see here, it's like, okay, we got monthly. Oh, I want to show monthly first. There we go. So, oh, let's see. Oh, that's right. So one thing to note about this, I forgot, is when we do the DFT temp resample, it's kind of passing a special object, just like group by. If you do a group by, right, on a data frame, it's not going to pass the data frame, it's going to pass a group by object. That's kind of what's going on here. So that's why we have to do these summative statistics in order to get something useful. So monthly mean, you can see here, is actually what we get. Oops, I don't know why I did this. Pass vector. Okay, there we go. Monthly mean. And you can see here, this is doing the aggregate like statistics right here. And you say, oh, there is some different means and stuff like this for each month. But we didn't actually change the data. So it's important to note that like df temp is still perfectly intact, right? You can see all the different days. So that's how we can basically take a resample. And now what we can do, you can basically keep this, and now this is going to be your data frame, for example. So if you look at month mean, you can see it's a data frame, and I can just, I could check the type in there, and it would be a data frame. Okay, makes sense? Cool. All right, so that's downsampling. You take something that has too much detail, like too fine detail, and you're basically downsampling it to a smaller amount. Whether that means because it's easier, because it's more efficient, or a lot of times you might do this because you want to combine data sets together, and it really only care about like every hour, or every day, or something like that, or every month. Okay. Upsampling. Upsampling is kind of the opposite, right? I put this little phrase in here, resample at a higher rate. That's kind of the terminology you'll hear a lot. And basically what it's saying is that you are, like when we talk about resampling, if you remember back in mod 2, when we talked about resampling for the first time, when we resample something, basically, or sample something, right? It basically just means that we're taking snippets from something. And we talk about random sample. Upsampling in this case is just basically saying we're going to take that value from the data frame itself and just kind of repeat it over, right? And so what's nice is that you never lose any information because you're basically just repeating information. Note that this isn't always the right way, even though you have more information. Again, imagine I have one room that has every second taking the temperature, another room's taking it every minute. I wouldn't want to upsample, I probably wouldn't want to upsample every room to be every second, because now it's like too much information, it doesn't really make much sense. But it might make sense if you want to combine data sets together, or you're trying to look at something broader. Maybe there's some missing values that make sense to be upsampled. Okay. So just to kind of quickly show you an example, you can see I'm doing a resample here. I'm doing 12 hours and then as a frequency. This is kind of a useful thing. Again, remember this is not a data frame anymore. This is a special kind of object, right? And so we can take this and we can say as the frequency, and you can see this bi-daily. It's kind of cool. So you can actually see here is that this kind of lets me see it. Okay, remember it was only every day. Well, now I have actually every 12 hours right here. So for example, let's just pretend that I know this data set right here is sampled, like, oh, it's the average from, 24-hour period from basically 12 midnight to 12 midnight, right? So that's kind of like this, I should say the minimum, right? That's what it actually is, the minimum for that day. But maybe I have another data set that's going to says, oh, they take the minimum from every 12 hours, right? Well, to combine those data sets together, it makes more sense for me to actually say, well, I don't know what the minimum was from that 12 hours, but I know it from this point, and having that sample like that. So then this becomes easier to combine together. Let's say, for example, is like, okay, like I actually do want to keep both parts in it. I can actually forward fill. That's what this F fill is. And you can see here, this will actually forward fill, where everything in the future will be forward filled from the past. So you can kind of think of like we're moving forward as we go down here in time, is that we're forward filling, right? So what would be the opposite of forward fill? Gotcha.
Backfill.
Backfill, right? And you can see the opposite happens, where basically the future fills in the past, right? So we're filling it backwards. So okay, pretty self-explanatory, right? And you can see here again, resampling, In this case, I'm doing 1 hour. So imagine we had 1 day, and now we're going to have 24 new points, right? And you can see our 24 hours, and then once we hit the 24th hour, we get the new data point. Okay, cool. Any questions at all on this? How are we feeling? You good? All right, cool. This is just handling data, right? This is nothing too fancy yet. But it's an important part, right? We want to make sure that we can actually get to this point where we can combine the data together. So let's go ahead and check out the next part, which is going to be visualization. So now what we have is basically we have our data, we have it loaded, and we're like, okay, cool. But now we want to like check it out, right? Remember, and if you guys remember, visualization to me is really important because as people, we like are really good at finding patterns visually. And for time series, like that's kind of like your goal, right? Most time you can look at a visualization and quickly find like an obvious pattern, or if that pattern makes sense. In fact, this is where I mentioned just a second ago that the curriculum actually might have filled it in wrong, or like actually didn't convert the date time correctly. And I noticed it because I was trying to do the same thing. It's like, wait, something's off. Like I can tell like this pattern doesn't exist in the way I think it should. And I realized like, oh, I'm reading it in wrong. And I said, oh, that's because I took it from the curriculum too. So that's what I'm talking about, where visualization can be so important. What's funny is that I didn't realize I've done this lesson before, and I didn't realize it until like recently when I was going through my lesson. So again, always check out your visualizations. Don't just assume they're correct, or assume that they say what you think it does. All right, so visualizing. So what's kind of about visualizing time series that you can do some really cool stuff, right? So the main thing is that we're showing changes over time, right? That's usually, I mentioned about showing distributions. That can be really useful, but usually when we're talking about time series, we're usually saying, hey, changes over time, right? Like that's the main focus, is the time aspect. So in this case, I'm just taking this New York Stock Exchange that's done every month. I think this is literally code from the curriculum. And note that I'm just saying, okay, I'm getting the column names. So it's a little bit easier for me to get here. I'm going to convert this into a date time, and then I'm going to set this in New York Stock Exchange data frame, set the index to this month column, and the in place equals true. So pretty straightforward, right? Okay. So we did this basic stuff, and you can see here, we get this nice date time, and you can see here, it is by month, right? You can see year, month, day. Note that when you convert to a date time, you can change the settings within Pandas, which is more work than it's worth. So in general, basically, dates are put as year, month, day, right? So that way you can always read it. Okay. And then note that, like we saw, let's quickly show it right here. If we have time, you can see the time is going to go very last. Okay. Cool. All right. So let's move on then to actually doing some stuff. So we can do some stuff like line plot, a dot plot, like a scatter plot. I call it a dot plot just because the curriculum calls it a dot plot. I would call it a scatter plot. We can check those out. So let's see what a line plot is. Well, we can do plot.show. And what's nice, because the index is the date itself, right? We actually just have the x-axis as the date. And it's nice that we can just have it broken apart exactly. We don't have to worry about ordering it in or doing some funky stuff or having a new index to make it an order. It knows it's in order, like it just goes for it, right? That's even true even if these different rows are out of order. You can basically have it say, hey, like even though these rows are out of order, it knows the date time is the important part. So it's going to plot it against there. So again, really convenient. And you can see in the stock exchange, it kind of, I think these are the returns every month. So you can, some months I have good returns over 1, or sorry, over 0, which means you have, you know, positive, you made some money, right? And other times I didn't do so well, right? Like you lost some money and stuff like this. And this is fluctuating from 1961 to 1967. So it's nice to kind of look and see a little bit what's going on here. And you can see here, just I'm kind of doing it at it and just like kind of reading off this data set. The first thing that kind of shows that to me is like there's fluctuations, and it seems to hover around 0, maybe a little bit above 0, but not by much. It's hard to tell if it's at 0. Like this seems relatively like flat. Like maybe it's a little bit above 0, but maybe not by much, right? At least the returns. And you can see too, is like over here, there's a lot less variation for like month to month, maybe, you know, between like 1963 and 1965 was relatively stable, but we can see some drastic changes over here, at least drastic in the sense of relative change. I'm not going to pretend to be like, no, I know exactly what these values are, but at least from these values, we see a lot more change over these years versus over this time period. Okay, cool. All right, so line plot, I think pretty straightforward. I think the most time what will probably happen if you make a mistake is that if you didn't set this as the index, and you try to do a plot like this and you're expecting this nice line plot and it's just like this weird like mess, like this is what usually people will see. It's like almost like someone kind of got one and it was kind of like almost like a spider that kind of came out like this. That usually happens because the index is set to something else. So the values are all over the place. So if you set the index to the date time, you know that's going to be nice and smooth. At least it should be. Okay, cool. So let's take dot plot. It's nothing too special. No, basically I'm just doing a plot, right? Just like I had like a line plot here. That's the default. If I do a plot, if I do style with this star right here, this basically means that, oh, like this is a map plot, right? This is matplotlib kind of notation. This basically says, oh, go ahead and make these dots, right? And you can see here, there you go. And I think if I do this right, you can actually have a line plot with your dots as well. So that can be convenient as well. But you can see if I had just the dots here, sometimes this is useful because you're not looking for the direct like bumping in like, you know, progression. Like you can see like this is kind of progression from here to the side. This might be more like, oh, there's a fuzziness into it, right? So you might want to look at an overall pattern that's kind of like changing over. Maybe you just want to look at the variation. For example, you can see there's very little variation here compared to over here. Okay. And of course, if you want a line plot with it, you can do this star, this asterisk with a dash. Okay, cool. Sound pretty good? All right, so dot versus line plots. I have question time. So know the difference between this line and this plot. What's my question? Task maker doesn't know how to ask questions. All right. When would you want to? When would you want a dot plot versus a line plot? So I kind of mentioned a little bit, but can someone give an example like when you might prefer something like this over something like this? This is the same data, right? So anyone got an idea like when I would prefer one over the other?
For like temperatures, you probably want a line plot versus the dot plot.
Yeah, I think.
I would say it depends how much I had to drink. Which one of those two I'd look at.
Now I'm curious, Alvaro. Which if you had a drink, which one would you prefer?
The dot plot. If I had a drink.
No, that's actually, I think it's an interesting one to note. So Uma, I think you actually have an interesting one where you say, oh, like you said, oh, if there's a temperature, we should use a line plot. But that also depends a little bit of like what they're taking the temperature of. Like I will say is that if I'm taking the temperature of, let's just pretend like a metal rod, like I'm working with a company and they want to see like the fluctuation of this metal rod that's super important to their, and they want to see the temperature fluctuations. I want to know how that temperature changes over time, right? Like maybe, for example, I know like instead of months, maybe these are like specific like minutes or seconds or something like that. And I want to know like, oh, I know at certain interval points that this is changing. Other times I would actually say like, if I wanted an overall view of like, well, how is the temperature changing in the room over time? And I want to see if there's a pattern amongst like the year, like maybe the temperature of the room should be consistent, but it actually might be getting colder or hotter. I might actually use a dot plot because every individual point doesn't matter as much. It's more like the overall pattern moving forward. And so I generally say use a scatter plot, a dot plot, if you're looking for an overall pattern. So you don't care about any specific point, or if you care about the specific point and you care about like the movement from this point to this point, like then a line plot makes a lot more sense because it's easier to see how these things change over time versus like if you look at like if I give you like this section right here, it's hard to tell which dot comes first. Like it's just harder to see that. And of course, if you want specific points, you can always do like this, but this is really a line plot with extra points, right? Okay. So I will say is that a dot plot, I tend not to do this if I'm looking for strict patterns because it can give you a very quick view of it, but it's not the best view. And so this is where we can talk about other different ways to plot as well, and we'll show a few of those things. Okay. Any questions of this difference between these two? It's the same data, right? Like there's nothing different about it. It's just how you view it and how our mind kind of like views that data when you plot it out. All right. So let's go into like groupings and plots. So let's say if we wanted to look at like year to year, right? So we didn't want to look at like, you know, all the years at once. We kind of say, what's this from January to December, right? January, December for each year, and then compare those years. Well, we can do a few things. So these are from the curriculum, but basically we can do things like we can group it by year. So what's nice is this thing called grouper. So remember group by, right? We can do a group by and we can say what we want to group by. Well, pd.grouper, what this is doing basically is going to create, it's kind of complicated to be honest. If you want to look more into it, you might want to look at the documentation for grouper. But the main idea you can kind of think of this is like it's grouping it into saying, okay, this is a group. It's kind of like adding an extra column saying, oh, this is all 1961 and this is all 1960, right? And then we're grouping it by that year. But instead of having to add a new column and saying, oh, this is year 1960, like this is the year, and then only having, how to say this? You have a column that has like 1960 and then all 1960 and then 1961 and then 1962 and so on, right? In the values, you basically say, well, I'm just gonna pass a grouper and it'll figure it out when it actually calls us over, which is kind of more efficient. And it's also a little bit easier to understand once you understand this grouper part. But this frequency is A. Anyone get an guess for what A stands for?
Annual.
Annual, right? Also yearly, which always just, this is why I have to look it up every time. I never remember like what it is. It's because I'm pretty sure like finance people probably do this and I'm not a finance person. So I don't think in those terms. All right, so we get our years group, and note that, remember your groups. You can see, hey, it's a group by object, right? So it's important to remember that. Okay, so then there's some fancy footwork over here. And it's from the curriculum, but it's kind of important to break down. So note that the curriculum here, and remember I just completely copied it directly, is the New York Stock Exchange Annual. It's making a new data frame right here. Remember this is grouped over here. And what's nice about this group by data, it actually has in this year groups, you can separate it by the year in the group. And by group, it's basically like a series, or it's almost like a mini data frame in a lot of ways. And the year is basically what group it's in. So we can separate those out saying get the year, get the group, like the data, from year groups. And then what we can do is say, okay, well, then in this data frame that we created, you can say this year.year is going to equal groups.values ravel. And so this ravel is like the one that messes people's brains. Like, what is this .ravel? Basically, it's just making it so it's a nice series versus like trying to keep it into like a tabular form. It makes it into like one nice long string, okay? So if you think of it, like if you didn't know what this was here and this was here, this is kind of like saying the data frame 1960, right? Unless like it's kind of like this, equals, and then it's like a series right here. Like this is a bunch of data. And so this 1960s column is going to have a bunch of data. Does that make sense? Okay, so that's what's going on here. So the year.year, it's kind of confusing. I don't think year would be, you could technically use the word date, but then it would like break it because you're using the word date. It's a reserved word. So for example, I would pretend like dt.year. Does that make sense? So it's like, this is the date and getting the year from that date. Okay. And remember, this is grouped by year. So we also know that anytime we do dt.year, it will always be a different year. If I do dt.month, that won't work out because it's my annual. Okay. Cool. So if you run this now, oh, so let me just run this so you can see what this looks like. And now if I actually show you guys New York Stock Exchange annual, you can see there it is. So you can see our column is each year, and then each one's the data in here. And note that this data right here, because it was it, I think it was it monthly? Yeah, it was New York Stock Exchange monthly. So each of these represent a month, which you can see there's 12 rows. So yeah, of course it's a month. So note that it's not explicitly stated here, but we know that's like, oh, this is going to be each month in a row. But it's going to make it easier for us to plot. Okay, does that make sense so far? Okay, cool. So now what we can do is like we can actually do subplots here and actually create a plot for each column in here. So if we run this now, this is really cool. You can actually see each row here, each plot is a different year. And we can actually compare these different years a little bit easier. Now, one thing to note here, you can also put in keeping the y-axis consistent. Note the y-axis is not consistent here, but at least we can see there's a different change, right, through time. If you wanted a y-axis to be consistent, you would have to define that up here in your subplots. Another matplot, you know, lib notation stuff, which again, you can go deep into matplotlib and all the different arguments. Because if you go check out the help docs in here, sometimes, oh, they actually show a little more information. Sometimes it's just like args, and it's like, oh, it just means matplot stuff, matplotlib stuff. Okay, so cool. So we can make this little plots. This is kind of nice, right? You can see each one. One issue that I have is like, well, we don't have the year or the Y value consistent, which we could change if we wanted to, right? But another part of this too that I don't like is like, once you have like many, many years, it's like, imagine if you had like 20 years and they're all stacked on top of each other. It's kind of tough to compare like 1961 to like, let's say like 1983. Like it'd be kind of tough to see that, right? In all one plot, and you'd have to like only plot those two next to each other. And it's like, I don't like it, right? It's not not the easiest thing together. And what if I just want to see, do they all follow the same pattern, right? It's like, all I want to know is like, hey, when do you tend to be hot in the year? And that's what I pull up. So another way we can do it is plotting them all together. So I like this one a lot because this is basically creating that subplot here, but we're going to actually put them all on one plot together. So note that I didn't do subplots. The subplots equals false, and I'll plot them all together, which is like, I'll say right now, it's not the prettiest looking graph, right? And it's probably because we don't have that many years and just some fluctuation, but at least then we can see them on top of each other saying, oh, are they following the same pattern? And from this I'd be like, I don't know, like maybe, like that's pretty much how I would bring this up. Maybe it looks like there's some pattern here, but it's like, it's too hard to tell. But at least if there was a lot of data in here, we could actually put it all together. And I'll show you that in a second. But yeah, these are kind of two ways we can group them together annually, right? And kind of see how we plot. Any questions on these two guys? How are we feeling? Thumbs up, thumbs down. Feeling good? All right, cool. All right, so we'll do our last visualization here. I think we'll probably stop it about there, but we'll see how we do. So one thing we can do is also show distribution of the data points. Now this isn't as super common. We'll kind of come back to some of this for heat maps. This is not really distribution in my head. Like this is kind of like heat maps as a solution to kind of like this kind of problem, but it is technically distribution. So one thing you might want to do this is just literally checking, seeing how do the points fluctuate in like in value. So, or like how the points fluctuate year to year. Like what are the different ranges, right, of like the values in that one year to another year. So a classic one we can do is a histogram. You can see here basically, this is kind of like stripping out the time information in some ways. We're still plotting and saying that it's still a monthly return, but it's saying, what are the monthly returns? Like, well, most monthly returns are either like 0.03 or negative 0.03. So you can see most of them are either one of these two, but you can see it kind of leans a little heavier on the positive side, right? You can see a lot more positive than over here than negative. So I would probably say, oh, that's probably a good thing, right? If you invest in the stock exchange, it probably means it's a good thing, right? You tend to get either break even or a little bit better than that. So this kind of gives you a distribution of it. If you wanted to make more or less bins, you can change the bins manually. You guys should know this already, just doing histograms, right? But you can see here, basically, we're stripping out the timed information in a lot of ways. We're just kind of seeing what's the what's the distribution of this data. Okay, cool. Then we have density plots. So KDEs, remember KDEs? Give me a thumbs up if you guys remember KDEs. Okay, seem reluctant thumbs up sometimes. That's okay. So remember, KDE stands for kernel density estimation, right? So basically, it's like a histogram, but it tries to make a really smooth plot on top of here. You can do different things to make different KDEs, like different strategies. But the main thing is like we make a nice smooth plot, so we don't have this blocky mess, right? Note that KDEs might seem more smooth than it really should be, but they can be useful for visualization. And you can see here, we see a general histogram right here. And you can see that general, like, oh yeah, it tends to be a little peaked up here, right? Or right here. It almost looks like if someone like, it almost looks like the opposite, like if someone took this as the data were real and then like converted it over to like blocky form, right? But just remember, this is technically a little more accurate than this by itself. I mean, I guess it depends how you look at it. Okay, so nothing too special, right? Yeah. Box plots, we all remember box plots. Thumbs up for box plots. Who feels comfortable with reading a block plot? Like, it's okay if you don't. Like, just give me a thumbs up if you're like, yeah, I feel really good. Just give me a thumbs up if you're like, I don't know. Okay, good. We're good with block plots. You have reached full data science potential, because I feel like I still don't like showing box plots to non-data science, non-technical people, just because I think it's a lot for people to not, it doesn't quite mix in their head. But if you guys can see it, it's good, right? So remember, box plots are basically just kind of like, I kind of like the idea of thinking like this box plot is a histogram, but it's just kind of like, it's like a summary of the histogram. So we can see basically like our average here, we can see our interquartile range, we can see our extents out here. And you can see, looks like there's a lot, like we saw before, there was a lot less variation in 1964 and 1965, which if you run all the way back up here, kind of what we expected, right? There's not as much variation in that time. And we can just see that visually very quickly with the box plot. So again, useful. It's still keeping this time information. So note that I didn't have to do special things like, oh, group it by dot plot or dot annual or something, because we already did that right here. So it makes it nice and easy to plot this out. Okay, so those are kind of fun. But I think the cool one is that we haven't talked about is heat maps, right? Has anyone used a heat map? I think maybe you guys might have used one. You guys might have used it for a project once, and I don't think everyone necessarily did. I see a lot of head nods. So heat maps are really useful because you can show patterns of data, and I love using heat maps for Pandas data because it's like very quick to see a pattern. So like I'm going to read this data in here, which is the min temperature, so not this New York Stock Exchange. Note that I'm using a different way to import the data into what's it called? Into a DateTime object, right? So note that before we had to like read the data, and then we had to do pd.toDateTime, and then say which one we wanted to convert to a DateTime, and then we had to do index. We can do this all within one call, the read CSV. And note that I separated this out, not that you should separate it out this way, I just made it so it's easier for us to kind of break it down. So first of all, we kind of go through here. It's like, here's the data to read it. Like, okay, cool. The index column, so basically says, hey, Pandas, when you read this data right here, treat the very first column as the index column. Note that you can also, for the record, you don't have to use for date, like time series stuff, right? But if you ever want an index where it's a multi-index, you can actually create an array, right? Or not an array, sorry, a list of like 0, 1, 2, like the first 3 columns are the index itself. So it can be useful. But since date's gonna be our first, it's gonna be our index, we're gonna see it there. Now this is the fun part, parse dates. So parse dates equals true, basically says, hey, it tells Pandas like, go find the date. Like you're gonna go look for dates and you're gonna make it into a DateTime for me, like, which is really sweet, right? Note that these next like 3 lines are gonna do things automatically, and just like with most automatic things, it might not necessarily be the most efficient, so you have to be kind of careful. Like a good idea is like if you have like huge data sets, is to test it with a small set first, see if that makes sense. Otherwise you do it manually. But for a lot of data sets, you're like, oh, just gonna throw up Pandas, do the work for me, Pandas. Like, why do I need to do it for you? Like, that's what you're here for. So parse dates, right? It's gonna say, all right, go ahead and try to parse the dates. Then we're gonna say infer DateTime format. So know that basically that means I don't have to pass this explicit way to convert the DateTime. Basically, Pandas is gonna try its best, just kind of basically automatically look to see what is the most obvious way to convert this into a DateTime and do that way, which is important because remember our min temp was it day, month, year? Is that right? I think, let's just double check that real quick. Yes, it was day, month, year. So you can see here, here's the day, here's the month, here's the year, right? So it's important because if you have the day first, hey, there's actually a day first, true. So this actually false automatically, right? And so I'll show you what happens when you run this normally. You can see our head.temp, and we can see, oh, everything's good. We can do our normal raveling and stuff like that, like we did before. Get our annual, and then we can actually plot them into each subplot like this. There we go. So you can actually see. And just real quick, I know we're getting close to time, so I'll go a little bit over. I'll come back to this, what happens if you don't set this to true. And this is what the curriculum actually makes a small mistake with. But you can see here, it's like, oh, okay, like I was saying before, we now have like, what's this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years, right? If I want to compare 1989 with 1961, is that really clear to you guys, like how that changes? Not really, right? Like it's like you got to squint. Like maybe I could just say, oh, maybe I'll just do just 1981 and 1989. It's so much more work, right? And like it's going to be so much work to try to figure something out, right? Especially if like only one of these is a weird year. Like I'd want to find that really quickly. And in my view is, what is this visualization really telling me? In my head, pretty much nothing. Like I can't quickly get information out of this just looking at it. So, and it's not bad, but it's like we could do better, right? So if I wanted to see, we'll do all of these years look similar to each other. And the New York Stock Exchange, we saw it like this. It's like, couldn't really see much of a pattern. What I like doing is temperature over the years, pattern all at once. You see, look at that. Look at that, that's beautiful, right? That's a beautiful mess right here. Because we can see there's a clear pattern, right? There's definitely like, it is higher over here, lower, whatever this mid, year is to end. So this mid year here, this is days, right? This is like July, right? So it's like, okay, it's hot here, cold here, hot here. Hey, what does that tell me immediately? It's either this is some weird data set or it's offset, or this is the southern hemisphere, right? Like it's it very quickly I can see this stuff. I can see there's fluctuation individually, but there's no one year that like really sticks out, right? You can actually see some quickly stuff. If these aren't the best colors for them, but you can see some quick, like, you know, very high values that are kind of sticking up here, and like the parts that like there are definitely some peaks. You can very quickly like pull out like what year is that? It's like, oh, 1982. Maybe it's something to look at for 1982. But the main thing is we can see that pattern. And that's what I'm talking about with the visualization. This, in my head, if you pull out a visualization, you do me this, oh, you made a fancy picture that means like nothing to me, right? It's important to say the context. So this is really nice, right? So to me, this is a beautiful like visualization, right? Now, how can we make it more beautiful, right? Well, heat maps. So we can actually create this heat map here. And remember here, like, let's say, for example, I just wanted to see like I want to see some patterns. I want to see what's going on here. And I can see like there's every year seems to follow the same pattern, but I can't see year to year really, right? So I kind of like, I would like to see every year individually, like see how it fluctuates, right? But I also would like to see the whole pattern. This is where this heat map's really useful. And you can see here, like I think I literally put here, like, it makes me want to weep. This is so beautiful right here, because like, if you look at this real quickly you can see like going from like the red, like hotter to like blue, like, you know, that's just the color scheme we used. But like we can very quickly say, hey, mid-year, it is a different value, right? They tend to be cooler and stuff. But look at this. I can also look at every individual year here and pretty quickly go across here and see which are the hottest and coldest days and what year they perform on. Like, to me, that's just like, this is amazing. Like, this is exactly what I want to like very quickly say, what are the patterns in here? And I can very quickly see this. And I can see, for example, like, oh, looks like these 2 years right here, the very first 2 years we logged, like had some much more extreme hot values. And then we can see it over here too. Like, we can very quickly pull out some values from this, just seeing from the heat map. So again, this is where I like to say visualization is really important, because people sometimes say like, oh, do a visualization, and like not really think like why you need to do that. It's like, oh, you do a visualization to inform you, right? Or inform someone else with your guidance. So this is where I'm saying like these two, I don't know. Every time I look at these, I'm like, oh, they're so beautiful. Like I could stare at these all day. I should frame them or something, like these kind of visualizations. But anyway, so this is kind of like this data set going through. Now I know I'm at time right now. So before I show you one last thing, I'm gonna hold off trends for next time, because I think it's important for us to take your time through it, plus we're out of time. But any questions on the things I've shown so far? Okay, see some head shakes, so. Okay. All right, so, oh yeah, go ahead, Christine.
Yeah, I'm sorry. About the heat map, I couldn't see the years. How to read it? Can you help?
Yeah, no, that's a good point. So it's not the most beautiful thing, right? But with some tweaking, you probably could, right? As you know, is that the year is going to be on this like rows right here. But you'll notice it's 0, 1, 2, 4, 6. And this is because we actually created to a matrix. We kind of trick the data, say, hey, don't show the years, try it by a matrix. And so it's just doing like, you know, the first year, the second year, the third year. You could technically change this over to like 1991, 1992, like in your visualization. But you can read it as like, this is the first year right here, the second year, the third year. I don't think you guys can see it super well. Maybe I can zoom in a little bit, but.
Like 1991, which one is that?
So the 1991 was the very, 1991 I didn't have, I think it's just 1990, right? But 1990 would be the very last row. Right here. Can you guys see that difference? Here, I'll tell you what, let me open this up in here. So you can see there's clear like distinction, like these blocks right here. This is not the 1990 block. This is the 1989 block. Does that make sense? So you can, yeah. And this is where like, again, like I said, it's like so beautiful and everything like that. Like, oh, technically you could probably make this a little clearer, right? By making these lines and stuff. But my theory is like, kind of like, well, if this takes me like no time to make right here, I can quickly pull this information out. If I make it really clear to someone, then maybe I could take some extra time to make this visualization really clear to someone reading it through. But hopefully that kind of helps. Does that make sense, Christine? Reading it?
Yeah, I just saw those numbers 0, 1, 2 till 62, I think. So
yeah.
Is it 10?
Yeah, so this is because it's a matrix. It's just counting it from 0, right? So I think you can probably play around with like the visualization of this plot and like force it to be like 19, whatever it was, 1981, right? And actually have it, the values shown here. But at least if you're kind of doing exploratory, like this would probably be a great exploratory graph, right? Visualization. But explanatory, you probably want to clean it up and like make sure it's really clear to whoever's looking at it.
Okay, thank you.
Okay, no problem. Okay, cool. So let's see if I can quickly show you what happens if you don't do this. So this right here, if you look at it carefully, you won't actually see right away like, oh, nothing seems too out of the ordinary, except you're like, oh wait, it's going from January 1st, February 1st, March 1st, and that's because instead of doing the day first, it's actually reading the month first. And if you do this now, I'm going to rerun these guys so we can make sure we have it. You're going to see more fluctuation. If you look carefully, like it doesn't look too different from before, but you see if you look like within a whole year, there seems to be a lot more fluctuation. And if I go ahead and plot this one out too, you can see, oh, there's a lot more fluctuation, right? And that's because it's hopping like this first day, second day, third day, fourth day is the first day of January, the first day of February, the first day of March, right? And so on. And so we can see it like a pattern and going up and down, up and down, up and down. And this is where visualization, if you see this, you're like, that's super weird. Like I thought it would, like I wouldn't expect it to change so much day per day, right? And you can very quickly say, oh, there's something wrong here. And this is actually what happened. So I'll tell you some quick background, right? And then we'll probably end it here, is that I was preparing for this next section over here, which we'll talk about assessing trends. And I was using the same data set right here, but I realized I've had a little error in my code where I didn't actually import the data, right? I just had this and I went to dftemp immediately. I was like, oh, I forgot to actually import it. So I just copied and pasted, I think the one from the curriculum, or maybe it was from here that was from the curriculum. And I pasted in here and it basically did the equivalent of saying day first equals false. So I won't show you guys right now, but like basically when you did the PD to date time and you put in the date, you're supposed to do a format. Well, they didn't put a format in the curriculum. And so it automatically did this. It basically tried doing this right here, equivalent to PD.toDateTime. It basically does the same exact function calls, which means it doesn't think it thinks the month is first, not the day is first. And that's when I was like, I looked at this like, whoa, like what the heck? Like, I'm like, I know this is wrong right here because I know this was a beautiful visualization and everything like this. And now it's all wonky and weird. And this is where like, I say like visualizations are really quick. Like I literally haven't noticed this for the past year that we were actually importing it wrong in the curriculum, at least for that one snippet. And you don't really notice it until like you see it visualized. And I almost want to pull up tell you what guys, I will show you guys what I'm talking about because I think it's such an important like it was exciting for me. I'm like, oh, like this is a perfect example of like why you should like visualize your data sets. Let's see here. Are you guys okay if I just go a little bit longer, like extra like 5 minutes? Okay, all right. I don't want you guys to feel like you have to stay if you need to go, but I want to show you where is the curriculum. Actually, you know what? I think I have it in display tabs. Hold on, I saved it for later. Let's see here. Okay, I think it's right here. Yes, all right, here it is. All right, so this is actually from the curriculum for basically types of trends, which we're going to talk about next time. But if you look at this is actually the min temp data, right? So min temp data, and you notice this is the part right here, PD.toDateTime, right? And you notice that there's no format. So what's happening, it automatically thinks that it's going to be month first, not day first, because I'm pretty sure most people who run Pandas were probably US citizens. And in the US, right, we tend to write the month first, then the day, not the day, then the month. So if you look at this carefully, there's a lot of fluctuation in between here. And I'll be honest, I've looked at this like same exact plot probably for over a year, right? And I never really thought much of it. Like I was like, oh yeah, we're looking for, periodically going up and down. We can see the years go up and down, right? As you expect, right? But I never really thought much of this fuzz in here. But when I think about it, it's like, oh wait, that's a huge fluctuation day per day or even month to month. And it wasn't until I literally had this visualization right here where I was like, whoa, like what's going on here? Like there's something up, like that's not normal. Like that's not what I expect from a year. And this is where I'd say the importance of visualization, right? Is that like visualizing something and visualizing it in a proper way in the sense that will show you insight is so important. And I just think it's such a great like example because it's like, if I've literally been using this visualization over and over and I never noticed that pattern. And it wasn't until I literally tried a different visualization in the incorrect way, right? Because I was using proper code before, that I noticed like, oh, there's something definitely wrong here. So anyway, I thought I'd show you guys that the reason why, the importance of visualization, especially for something like this, where you should have your expectations set in your mind, like, what should this be? And if it doesn't fit your expectations, you know, be skeptical of your data. Make sure, like, does this make sense? Okay, cool. All right, so I know I went a little bit over, but hopefully you guys found that useful and everything. It's great to see you guys all back and everything. I'll stop the recording here. So I think unless there's any other questions. No? Okay.